All right. So we got, like I said, as promised, you're going to get 4 examples of the mole equation each day this week. You got 4 yesterday, you're going to get 4 more today, you're going to get 4 more tomorrow, okay? And either Thursday or Friday, you'll get another 4, okay? It would be a good idea to watch the podcasts. If you're struggling with that, you can watch all of those examples again. There's not going to be any tricks. I'm going to ask the mole equation on the unit exam exactly the way I'm asking it here, okay? Because there's only 4 ways to do it, all right? So the only thing that's going to change on your test is what material I ask about and how much of it there is. That's all that can change. The format of the questions is always going to be the same. Okay? Everybody follow me there? All right. So for question number 1 here, we're asked how many moles of carbon dioxide are there in 150 grams? Yeah, if we recall, the mole equation is number of moles equals mass in grams divided by molar mass. This molar mass is that thing we calculated off the periodic table. Okay? So, what 2 things have they given me in this question? They've given me mass, 150 grams. What else? They've given me the formula or the compound so that I can get molar mass. All right, so I've got 2 out of the 3 things. I'm being asked to calculate how many moles. That's N. All right, so our first step then is to, whoop, didn't mean to have all that on there. Okay, so our first step is to write down our given. That's not even the right question. No, we can fix that problem. Okay, so now we're, come on. All right, so our givens are in this question, little m, 150 grams, okay, and the material, carbon dioxide. And remember that I told you yesterday, I'm probably not going to be that nice on the unit exam. I'm not going to give you the formula. I'm going to give you the name. Okay, it'll say carbon dioxide, and you'll have to get to the formula by remembering your naming and formula rules. All right, so to calculate the molar mass of this, how many carbon atoms are in this compound? 1. All right, carbon's 12.01. Okay, and there are 2 oxygens. So 2 times 16, the atomic mass or molar mass of oxygen atoms. All right, so we're going to have 32 plus 12.01. That should be 44.01 grams per mole. All right, I have little m and now I have big M. So now I should be able to calculate N. Do I have to manipulate the equation at all? Not for this one. This is the easiest one. Okay, we've got mass, 150 grams, divided by molar mass, which I just calculated, 44.01 grams per mole. And incidentally, you would not be expected to put the units in while you're calculating, but make sure you have units on your answer. All right, so I'm dividing grams by grams per mole. That's going to leave me with moles. Okay, 150 divided by 44.01. 3.41 moles. Okay, everybody all right with that one? So that would be one that would be worth only 3 marks. You would get 1 mark for your givens. You would get 1 mark for plugging your numbers or substituting the numbers into the formula correctly, and 1 mark for your final answer. Make sure it has units, okay, or you'll lose the mark for the final answer. Well, because it isn't grams per mole, right? Grams per mole. This is the mass of 1 mole. That's why it's in grams per mole, right? When I divide grams by grams per mole, the grams cancel, right? Okay. All right. Does anyone still need this one? Back to question number 2 here. Okay, so we've got a question that's asking us to calculate the mass, which means it's asking us to calculate little m, of 26.5 moles. So what did they give me there? N, right? Okay, of cobalt 2 bromide. Okay, I know it's cobalt 2 because okay, when we swapped and dropped, the 2 ended up over here. All right, so we've got molar mass here being COBr2. So cobalt, I can never remember that one, 58.93. Do I need to multiply that by anything, or is there only one? There's only one. Okay. And there are 2 bromines, so that's 79.9 times 2. Okay, 218.73 grams. Okay, is our, grams per mole is our molar mass. Okay, I have N and I have big M, and now I'm looking for M. I want M by itself. What do? Multiply which one? Big. Right, I got to move big M over to this side. Right now I'm dividing by big M. Okay, so our rules of algebra are if you want to move something, do the opposite. So I multiply. Second rule of algebra, what you do to this side, do to the other side. So I have M times N. Okay, now I can plug in my numbers. So we've got our 218.73 grams per mole multiplied by our number of moles, 26.5. Gives us a lot, okay? 5,796.35. 2 decimal places will be sufficient for all of your mole calculations, okay? And that's going to be in grams. All right, so we got almost 6 kilograms worth of this stuff, so quite a bit. All right, so 1 mark for your answer, 1 mark for your substitution, 1 mark for your manipulation, okay, and 1 mark for your givens / calculating the molar mass. 4 marks for that one. Any questions on how that one works? All right, so those 2 are the ones that do not involve using Avogadro's number. Okay, the next 2 involve using Avogadro's number, which tells us what? No, sorry, I mean, what does Avogadro's number tell us? Okay, not the mass of 1 mole, but the number of molecules or particles in a mole. Okay, the mass of 1 mole is this number, right? Molar mass. Okay, that's the mass of 1 mole. Avogadro's number is the number of particles in a mole. Okay, if it's water, it's the number of molecules in a mole. If it's an element, like sodium, it's the number of atoms in a mole. It just depends what you're dealing with. Are you dealing with something that is an atom, or are you dealing with something that's a compound, thus a molecule? Okay. All right, third one. Okay. So this time it's asking us for the number of molecules. And we said anytime a question mentions molecules, either asks you to calculate it or gives it to you, you're going to be using Avogadro's number, because Avogadro's number can convert moles to number of molecules or number of molecules back to moles. That's what we use it for. All right, so here's what we were given. We were given the material, sodium sulfide, and we were told the mass, 29 grams. Okay, we're being asked to calculate the number of molecules. Okay, what can I calculate right now that I have little m and big M? I can calculate molar mass. Yeah, I'll do that first. Okay, so we've got 22.99. This is the molar mass of sodium. How many sodiums are there? 2. Right, so I got to multiply that by 2. Okay, plus a sulfur, which is 32.07. Okay. So 22.99 times 2 plus 32.07. All right. Whoop. Plus 45. All right, 78.05 grams per mole. Okay, now I have little m and big M. What can I calculate with those? I can calculate N, number of moles. All right, so little m over big M. I don't have to manipulate it. It's already set up for what I want. So I plug in my numbers. 29 grams divided by 78.05 grams per mole. Do I have less than a mole here? Yeah, I do. Okay, this is the mass of 1 mole. I don't have that much, so I'm going to get a decimal. That's okay. So 29 divided by our molar mass. All right, so we have 0.372 moles, okay, of this stuff. So 0.372. All right. I know the number of moles, and now here's where Avogadro's number comes in. Okay? This number is the number of molecules in a mole. This is the number of moles that I have. I want to get number of molecules. What do I do with these two numbers? Multiply them, right? Okay? If I have 2 moles, I multiply by the number in a mole. It tells me how many I have. Okay? All right. So number of molecules is going to be N times 6.02 times 10 to the 23, which for us is going to be 0.372 multiplied by Avogadro's number, 6.02 times 10 to the 23. Now, remember, when you punch this into your calculator, it's a bit of a mess. So I'm going to take my full number here that I calculated, okay, and just use it again. And I'm going to multiply that by Avogadro's number, which has to be enclosed in brackets, 6.02. Okay, and then we use the EE button, or if your calculator doesn't have it this way, EXP, okay, something like that. And then we put the exponent on there, 23. Right? The E stands for times 10, and whatever comes after is the power of 10 that's going to be on there, in this case 23. All right, so what we end up with is this, 2.24 times 10 to the 23 molecules. Okay, questions on that one? Hannah? Yes, because if you write an abbreviation, it'll seem like it's moles. Like MOL is the abbreviation for moles, and that's different. Yes, so do please write the full word molecules when you're solving for molecules. Any other questions on number 3? Okay. All right, so our last example here goes kind of backwards from the one we just did. We start out with the number of molecules. Okay? They tell us the number of molecules is 7.2 times 10 to the 23. Okay? They also tell us what molecules we're dealing with. Diphosphorus pentaoxide. All right, so we're going to have 30.97. Yeah, times 2. There's 2 phosphorus. Okay, plus 5 oxygens. Okay, so we're going to have a molar mass here of 141.94 grams per mole. Okay, I'm being asked to calculate little m. What else do I need in order to get little m? Number of moles. Okay, I need n. Now, just a minute ago, I used n to calculate the number of molecules by multiplying it by Avogadro's number. Now I want to go the other way. I want to get the number of moles. So I take what I have here and do what with Avogadro's number? Divide by it, right? If I divide by Avogadro's number, now I've got N, okay? It's just kind of switched back and forth, right? All right, so N is going to be the number of molecules divided by Av's number. Okay, so that's going to be 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. All right. N equals. Can I shortcut on my math on this one? They're both times 10 to the 23, right? So do I need to write in the 10 to the 23 on both of them, or can I just skip that part? I can skip that part. If you're not comfortable with that, don't, okay? If you're not comfortable with skipping it, put 10 to the 23 in for both of them. But since they have the same exponent, we can just divide the bases. All right, so we have just a little over 1 mole. We have 1.20 moles. All right, now I have moles, and I have molar mass. Can I calculate M? Yes, I can. All right, so now I go back to my formula. N equals little m over big M. We have to manipulate it. Okay, so we got to multiply both sides by M, big M that is. Okay, and now we've got little m, so that'll be our 141.94 big M multiplied by 1.2, not 7.2, 1.2. Okay, which is our number of moles here. Okay, so 169.76. What are my units for that answer? Grams. Okay, so this question here is worth the most marks, right? You get a mark for your answer, okay? You get a mark for your substitution, a mark for your manipulation, okay? A mark for this step, calculating N, and a mark up here for your givens. That's a 5-mark question. All right, is this starting to make a little bit more sense? It makes more and more sense every day this week, trust me. Okay, the first day it's pretty intimidating, okay? But once you realize there's only 4 kinds of questions I can ask, it becomes pretty mechanical. Okay. All right, you have that worksheet on, oh no, sorry you don't. I photocopied it for you though, and I will give it to you on moles, okay, for today. That's what we're going to be working on. Okay, so on my website you can see the key for that worksheet. Okay, so go into chemistry, right, and obviously the worksheet. Okay, the worksheet is lesson 21, the mole equation here. Okay, and then if you go down towards the bottom where all the keys are, it says keys to all mole equation worksheets. Okay, that's, if you click on that, okay, you'll be able to see the solutions there in my chicken scratch. Okay, if you recall, right at the end of the day yesterday when you guys didn't have the sheet, you were just working off the board, okay? Remember that we said question number 1 is the one people overthink, okay? If I have 1 mole of anything, I have how many? Avogadro's number, okay? Remember, in 1 mole, there are 6.02 times 10 to the 23 particles. In this case, they're atoms because it's an element, okay? For our next one here, in 2.5 moles, I would go 2.5 times Avogadro's number, okay? And that would give me the number of molecules, or in this case, sorry, atoms of helium. Okay, everybody follow me there? This one's, it's a lot easier than people make it out to be. People are always trying to do an N equals little m over big M calculation for question number 1. It isn't that kind of question. Okay? It's just asking you, can you use Avogadro's number? Right? After that, now these ones here, these are N equals little m over big M. Okay? And as you go down the list here, you'll have more N equals little m over big M ones. How many oxygen atoms are in 64 grams of oxygen gas? Now, really all this question is asking is, do you know the difference between a molecule and an atom? Okay? Right now, I'm looking at O2. Is that a molecule or an atom? It's a molecule. Okay? If it was an atom, it would just be O. Right? So this is a molecule. So when I do all this, usually people set it up and they go, okay, there's 2 oxygens, so big M is 32 grams per mole. And they're right. Okay? That's the mass, the molar mass of a molecule of oxygen. Right? And then they tell us there's 64 grams. So they go through this and they say, okay, 64 grams, the mass, divided by 32, the molar mass, gives me 2 moles. And they're right. Okay? Then they go, all right, I got to multiply that by Avogadro's number. Okay? So they go 2 times Avogadro's number, which gives them 1.204 times 10 to the 24. Well, here's where they go wrong. They look at that and they say, I didn't get the right answer. Well, you're right, because you got one more step. You just calculated here the number of oxygen molecules, O2. You did everything with 32, the mass of an oxygen molecule. The question is asking, how many atoms? So if this is the number of molecules, and every molecule has 2 oxygen atoms, what do I have to multiply this by? 2. If you find that you do that, you'll get the answer I have on the key. Okay? Which is 2.404, right? Or 408 or something like that. But, right, exactly.